Hi everyone, welcome. My name is Jay, a graduate student from HDSI UCSD. Today I wanted to spend a couple minutes to introduce a very important and a very common concept in machine learning, which we call it overfitting. Okay, so first, what's overfitting? Uh, Let me give us an example. So now if we have a data set which it's include the house price and an area. So like for the x axis we write its area. So for the y axis we make it price. The data set is looks like this. Okay, so our job is to fit a model to predict to fit model for this data set. Okay, looks like a linear relationship or linear trend, right? So probably we can fit as a linear uh, as a as a line. Probably it looks like this. Okay. So we could call it model A. Uh, it looks like it fits very well uh for this data set. But probably some students may want to say, no, it's not. It's you can see it's almost every data of the data set is not on this line. So now the question is, can we find a better model, a perfect model to fit all the data in this problem? We could try it. Like if we use a red line to fit all of the data in this data set. Okay, so now we could call it the model B, the red one. Uh, the model B, it fits the data, each of the data perfectly. So now can we see the model B? It's much better than the model A. Can we? No, we could not see that. The true test of a model is not how perfect fit of our training data. It's how well it predicts the new data, which we have never seen before. So it assume we have a new price, new house, which just listed on the housing market. So it's really the green star. Uh, we can see the price. The Model A predicts the price of the greenhouse very well. It's very close, right? It's very close. But where is the Model B? Model B is right here. It's much more here than the actual price of this house. So what happened? Why the Model B fits the training data very well, but it cannot predict the new data? What happened? So that's the question. That's because the model B didn't then the train, it just fit the training data, but the training data is not a perfect one. It includes some noisy. So the model B has uh it includes many noisy. It just based it on basically memorize the data set, but it cannot or it predict very bad on the new data. That's we call it overfitting. So there's another example, uh, said like for an exam. So the training data, its practice problems, and the test data, its final exam. So the model A is a student. He can totally understand the concept and the knowledge in the lecture, and even he has some mistake on the practice problems. But when he totally understand what's going on, and if he met some new question on the final exam, he almost can solve it very well. But for the model B, the test data, he for the model B, like like the student, he didn't totally understand the concept. He just tried to memorize the solution of the practice problems. So if he met some question on the final exam, which is is almost same with the practice problem, he can do it very well. But that's not happen if in the final exam, probably there's some new question which we never seen it before. So model B cannot predict or cannot solve it totally. So that's we call this overfitting. So overfitting, the concept is when our model learns the training data too well, it becomes too complex, capturing some noisy instead of truly underlying the pattern. And as a result, it failed to generate or predict to the new data. Okay, thank you. My name is Jay. Thanks for watching. Hope you have totally understand the overfitting. Okay, bye.